Hello everyone, this is Dnyaneshwar Sanap working as an assistant professor in the Department of Chemistry at Maratha Vidya Prasarak Samaj, Arts, Commerce and Science College, Dindori. In this video lecture, we will discuss about the IUPAC nomenclature for an coordination compounds. Nowadays, the vast number of coordination compound is already exist and almost unlimited number of coordination compounds yet to come. That's why it is essential to develop the systematic and commonly acceptable naming system for the coordination compounds. And to give the systematic name for each coordination compound, the International Union of Pure and Applied Chemistry, that is IUPAC, developed some rules for the developing of name for each coordination compounds, and that we have to learn one by one in this video lecture. Let us see the first rule. When complex ion is anionic in nature, that means the anionic complex ion is present. Let us see the example. K2PtCl6. Split this complex in the ions separately, like K plus ion and PtCl6 minus 2 ion. This PtCl6 2 minus is known as complex ion. Basically, metal atom or ion and ligands present in the square bracket is denoted by the term known as complex ion. And this complex ion having negative charge, that's why it is called as anionic complex ion. When such a type of complex is present, then we have to write the nomenclature for such coordinate compound like this one by one. First of all, we have to write the name of cation, that means K plus ion, that is potassium ion, followed by the name of anionic complex. That means we have to first of all write the name for the cation which is present outside the complex in the coordination compounds. After that we have to give the space, and after that we have to write the name of complex ion without space. The next important point is name of cation and the anion in the square bracket is separated by space. That means after writing the name of cation, we have to give this space for the writing the name of this complex ion. The third important point is writing the name of ligand which is present in the square, that means which is present in the complex ion. But the ligand having three types, as we know that. That's why we have to write first of all negative ligand names. After that we have to write the neutral ligand names, and after that we have to write the positive ligand name. Here only one type of ligand is there, that's why there is no need of sequence. But when the different type of ligand is present, then we have to keep in mind the sequence of writing the ligand. This is the first case for the writing the ligands one by one. But when any coordination compound having two or more one type of ligand, that means when molecule having two different negative ligands, or molecule having two different neutral ligands, or molecule having two different positive ligands, or so on, then we have to write this ligand in this order, but we have to also maintain the alphabetical order of same type of ligand. That means when two or more negative type of ligand is there, then we have to write the negative type of ligand with the alphabetical orders from A to Z. Similarly for neutral also, similarly for positive also. That we discuss with the help of example in the next. The fourth important rule is, if ligand is more than one, then add the prefix before the ligand. That means di, tri, tetra, penta, hexa. Let us see how. In this case, basically chlorine ion, that is Cl minus ion, is 6 in number in the complex ion, and that's why we have to write the hexa before the writing the chlorine. Is it clear? The fifth important point is, if the ligand has already prefix like as di, tri, tetra, etc., then we have to write the bis, tris and tetrakis as an prefix before the ligand. That we discuss in the example. That means we have to keep in mind there is presence of these words di, tri, tetra and penta or hexa in the name of ligand, that time we have to avoid the writing of prefix like as di, tri, tetra. Instead of we have to write the bis, tris and tetrakris as a prefix for the writing of name of ligand. The sixth important point is, for the anionic complex ion coordination compounds, we have to write the metal atom or metal ion name with the suffix ATE, because complex ion is an anionic in nature, and that's why we have to write ATE as a suffix for the metal atom or ion during the writing of name. The seventh important point is, after writing the suffix without space, we have to write the oxidation state of a metal atom or ion in the Roman digits in the bracket or in the parenthesis like this. Example of anionic complex ion is K2PtCl6, and the IUPAC nomenclature for the same coordinate compound is potassium hexachloroplatinate 4. Let us match this name with the above 7 rules. First we write here potassium, and after that we give the space here now. Potassium is first right here because this is cation present outside the square bracket in the coordinate compound, and that's why we write it separately. After that we write the one word name of complex ion without giving this space in between any type of prefix, suffix, as well as name of ligand, as well as name of metal atom or ion and oxidation state. The complex ion basically name according to the remaining rules. In this case basically, first of all we have to write the name of ligand according to the rule 3rd. There is only one type of ligand, that's why we write here chloro, but there is 6 ligand present of an chlorine ion, that's why we write the prefix hexa before the chloro. After that the name of metal atom according to the rule number 6, that is platinum, but the complex is anionic, that's why we write here ATE as an suffix during the writing of IUPAC name. After that without space we write here the oxidation state of an platinum. Basically here 6Cl- ion is attached to the platinum metal ion and 2 potassium cation is present here, and that's why the oxidation state of platinum is 4, and we write this oxidation state in the parenthesis without space between the metal atom and oxidation state number. Second example is K3FeCN6. In this case basically 6 Cn- ligands is attached to the Fe atom, and outside the square bracket there is 3K plus ion, that means the oxidation state of Fe is +3, and that's why we write the name of K3FeCN6 like this: potassium, after that space, after that number of ligand present, that is hexacyano, after that name of metal atom with the suffix ATE, that is ferrate, and the oxidation state of an metal atom, and that's why the resultant name is potassium hexacyanoferrate 3rd. This is all about the nomenclature for the anionic complexes or anionic complex ion. The next type of complex is cationic complex or cationic complexes ion, and the example is CO cobalt NH36 Cl thrice. Split this complex in the cation and anion like this: CONH thrice 6 plus 3 and 3 Cl minus. The first rule to nominate cationic complex ion is cationic complex name first followed by the full name of anion. That means we have to write the first of all name of this complex ion, that is cationic complex ion. After that we have to write the name of anion which is present in the coordination compound. During writing the name of such a kind of complex, we have to keep the one space between the name of these cationic complexes and these anions. The third important rule to write the name of cationic complex ion is write the name of ligand with the sequence like this. Negative ligand first, after that neutral ligand, after that positive ligand. But when the two or more ligands of each type is present in the cationic complex, then we have to write the each type of ligand with the alphabetical order one by one without disturbing the sequence of types of ligands. The fourth rule is if the ligand is more than 1, then add the prefix before the ligand, that is di, tri, tetra, penta, hexa, etc. The fifth important rule is if the ligand has already prefix like as di, tri, tetra, then we have to write the prefix like bis, tris, tetrakis, etc. before the ligand. But during the writing of such type of ligand name, we have to keep in mind, we have to always write the name of such type of ligand in the bracket always after the writing of prefix like as bis, tris and tetrakis. The next important rule is followed name of metal, atom or ion without space we have to write the suffix IUM. In first case, that is anionic complex ion, we write the suffix AT, but for cationic complexes we have to write the suffix IUM for the metal ion. The next important point is write the metal oxidation state with the Roman digits in the brackets or in the parentheses without space between the metal ion and its oxidation state. And the last important rule is followed by the space. Lastly, we have to write the name of anionic ligand. That means this part. The example is dichloro tetraaco chromium third chloride. Here the name of whole coordination compound is right in the two words only, and we have to keep in always mind, we have to write the name of any anionic as well as cationic coordinate complex molecule in the two parts only or in the two words only. For neutral coordination compounds, we have to write the name in only one word. Here we have to write this whole molecule name in the two words. The third important rule for the writing the nomenclature is for non-ionic complexes, that is the complex which is neutral in nature. The example of such kind of coordinate compound is CONS3 thrice Cl thrice. Let us see one by one. When complex is non-ionic, then we have to write the name of whole complex in the one word without giving the space between the name of ligands and name of metal atoms. The second most important rule is write the name of ligand according to the sequence. First of all negative ligand, then neutral ligand, then positive ligand. When two or more ligand of each type is present, then we have to write the ligand in the alphabetical order one by one. The fourth important point is if the ligand is more than one, then we have to add the prefix, that is di, tri, tetra, penta, hexa and so on. But when the ligand having already prefix like di, tri, tetra, then we have to write the prefix like bis, tris, tetrakis for the such type of ligand. But after writing these prefixes, we have to write the name of ligand in the bracket always. The sixth important point is followed by name of metal, atom or ion without space and without any suffix. That means after writing the name of ligand, we have to write the name of metal, atom directly without writing the any kind of suffix, that is ATE or IUM, as like in the cationic or anionic complexes. The seventh important point is write the metal oxidation state with the Roman digits in the bracket or parenthesis without space. And the example is CONS3 thrice Cl thrice. In this case, basically two types of ligand is present. First one is ammonium ligand and second one is chlorine ligand. There is competition between the two ligands to write one by one. To avoid this confusion, we have to take the help of rule number second. First of all, we have to write the ligands in the sequence order of negative ligand first, then neutral ligand, then positive ligand. And out of these two ligands or these two types of ligand, chlorine is and ligand which having negative charge on it. But ammonia is a neutral molecule. That's why we write the chlorine as an first, after that the neutral ligand, and after that name of metal atom. But here 3 ligands of chlorine ion is present. That's why we write first of all the prefix tris, after that the name of ligand, that is chloro. After that we comes to the writing the name of second type of ligand, that is neutral ligand, that is ammonia. But in case of ammonia also there is 3 molecule of ammonia is participate for the formation of coordinate bond. That's why we write here tri, after that name of ligand, that is ammonia, after that name of metal, that is cobalt, without addition any suffix here. And lastly we have to write the oxidation state of an cobalt, that is +3. Here this ammonia molecule is neutral in nature, that's why there is no contribution is neutralizing the charges of cobalt, but there is presence of chlorine ion, that is Cl- ion, which having -1 oxidation state, and there is total 3 chlorine atom. That's why the total charge contributed by the chlorine is -3, and this 3 is equivalent to the +3, and that's why this complex is neutral in nature, and that's why the oxidation state of cobalt is +3. Here we have to write whole nomenclature of non-ionic complex in the one word only. Did not write the name in the 2 or more words for the non-ionic complexes as like to the cationic or anionic complexes. The second example is PTNS thrice twice Cl4. Here 2 ligands repeatedly, chlorine and ammonia. Chlorine is -1, ammonia is neutral 1. That's why we write the name of chlorine first of all, after that ammonia. Okay. There are 4 chlorine anion is present. That's why we write the prefix tetra, chloro. 2 ammonia molecule, that's why di, ammonium, metal is platinum, that's why we write the platinum, and the oxidation state of platinum is +4. And the resultant, the name of complex is tetrachloro diamine platinum 4. The fourth important rule is naming of ligand. Basically, there is 3 types of ligand present in the coordination compounds. First type of ligand is neutral ligand, second is negative ligand, and third is positive ligand. While writing the naming of ligand, we have to keep the certain rule in our mind to avoid the mistakes. First of all, neutral ligands. For neutral ligand, name as the molecule without special ending. That means whenever neutral ligand is present in the coordination complexes or molecule or coordination compounds, then we have to write the name of ligand as a molecule without special ending, that is special suffix for the ligand. The example of such kind of ligand is NH2CH2CH2 NH2, that is ethylene diamine. In this case, here the name of this molecule is written as it is for writing the nomenclature of a molecule. Another example is triphenylphosphine. The exception case for the neutral ligand is, let us see one by one. H2O molecule. Basically water molecule ligand name is not right water molecule. Instead it used echo for the naming. The second exceptional case is ammonia molecule. Basically NH3 molecule ligand name is right as an amine. In this case, writing the spelling of an amine, we have to write the double M, that is 2 times M for the amine ligand. But other than this NH3 ligand, we have to write only single M while writing the name of amine ligands. Let us see example here. Ethylene diamine. Here we write here only single M instead the double M. That means for ammonia molecule ligands, we have to write the double M, but rather than ammonia molecule, we have to write only single M. The third case is phenylamine. Here also we write single M instead of double M. That means rather ammonia molecule, we have to write the amine as an AMINE, but for ammonia we have to write the amine as an AMMINE. The fourth case is carbon monoxide. Instead use the carbon monoxide, we have to write the carbonyl. Next case is nitrogen monoxide. Instead of using the nitrogen monoxide, we have to write the nitrosyl. The next type of ligand is negative ligand. While writing the name of negative ligand, we have to write the name of ligand with the suffix O. That means whenever you write the name of negative ligand, we have to add the suffix of O. The example of such type of ligand is fluorine anion, and we have to write this ligand name as a fluoro instead of fluorine. For chlorine anion, we have to write the chloro instead of chlorine. For bromo anion, we have to write the bromo instead of bromine. For iodo, we have to write iodo. For cyanide anion, we have to write cyano. For NO2 minus ion, we have to write the nitro. For NO2 minus but ONO minus, we have to write the nitrito. NO3 minus, we have to write the nitrito. NH2 minus, we have to write the amido, and so on. Next type of ligand is positive ligand. While writing the name of positive ligand, we have to add the suffix IUM after the name of ligand. Let us see example. NO plus ion. The name of nitrosyl oxide ion is nitronium or nitroselenium. The second example is NH2NH3 plus. This is the hydrazine derivative. In this case, basically, this lone pair of nitrogen is easily available for the donation, and this other part is protonated, and that's why the whole ligand is positive in nature. And the name of such type of ligand is written like as hydrazium. The next important point is order of listing of ligands. If two or more types of ligand is present in the square bracket, then ligand should be naming as first of all negative ligand, then neutral ligand, and then positive ligand. If more than one ligand of same type is present among the above three types, then we have to write the name of ligand according to the alphabets. That means when two or more ligand of negative types or neutral types or positive types is present, then we have to write the ligand in the order of alphabets. Third important point is, if any ligand is present more than one time, use the prefix like di, tri, tetra, penta, hexa, etc. The fourth important point is, if ligand molecule having di, tri or tetra words already in the name, then we have to use the prefix like follows. For di, we have to use the bis. For tri, we have to use the tris. For tetra, we have to use the tetrakis, and so on. The fifth important rule is, when ligand having prefix like di, tri, tetra, penta, etc., then write the such ligand names in the bracket after the writing the prefix, that is bis, tris or tetrakis. The sixth important rule is, after naming the ligand in the square bracket, write the name of metal atom or ion with the oxidation state in the Roman digits in the bracket or in the parenthesis without giving the space. Let us see the one example. COAN twice Cl twice Cl. Here there is two sphere present in the coordination compound, that is coordination sphere and outer sphere. Coordination sphere is denoted by the square bracket. Basically, in square bracket there are two types of ligand present. First one is chlorine anion ligand and second one is EN, that is ethylene diamine ligand. And out of square bracket there is one chlorine anion present. This is an cationic ion complex, and that's why we have to write first of all the name for the square bracket, and after that by giving this space we have to write the name of this anion. While writing the name of such type of complex, we have to follow the one by one rule. Here two ligands, first one is neutral one and second one is anionic, and out of these two we have to first of all choose the naming of negative ligand first of all according to the rule first. That's why we write the name of chlorine anion first of all. But here two chlorine atom is present, that's why we write the prefix di, after that chloro. But here ethylene diamine is a ligand in which di word is present already in the name of ligand. That's why according to the rule number 4, instead of using the di, we write here the bis as a prefix, and that's why the name of ligand is right like bis in bracket ethylene diamine. Here bracket used according to the rule number 5. After that name of metal ion and without space the oxidation state of metal atom. After giving the space, we have to write the name of anionic part in the complex, that is chloride. And the name of this coordination complex is like dichloro-bis ethylene diamine cobalt 3rd chloride. The next important point is oxidation state. Basically, oxidation state of central atom or ion is shown by the Roman number as 0, 1, 2, 3 in the bracket or in the parenthesis 1 by 1. Second important point is do not give the space between the atom or ion name and the oxidation number. Third important rule is for positive oxidation state, do not write any sign before the Roman numbers in the parenthesis. Fourth important rule is for negative oxidation state, write the minus sign before the Roman number in the parenthesis. Fifth important rule is for zero oxidation state, write the 0 in the parenthesis always. Do not avoid the writing of 0 in the parenthesis. Let us see the example of some complexes. Sodium tetra carbonyl cobaltate in the bracket -1, because here sodium is an cationic species outside the square bracket and the charge over the complex is an negative, because carbonyl or carbon monoxide ligand is a neutral in nature. That's why we write the minus oxidation state. Second example, K4NiCN4. The name is potassium tetracyanonickelate 0. The next important point is point of attachment. If unidentate ligand has more than one atom which can donate the electron pair, it becomes necessary to show which atom is acting as a donor. Symbol of donor atom is written after the name of ligand with the separation of hyphen. Let us see the example. Ammonium hexathiocyanate N chromate 3rd or ammonium isothiocyanate chromate 3rd. Basically, there is only one ligand, but this ligand having tendency to donate the electron pairs via two atoms, that is nitrogen as well as sulfur, and that's why we have to write which atom is responsible for donation of electron density to the central atom or ion. Here nitrogen is donate the electron density to the chromium atom, and that's why we write the symbol of nitrogen element as a N after the name of ligand and before the name of metal atom by the separation of a hyphen. Second example is ammonium hexathiocyanate S platinate 4. Here same ligand is present, but the donor atom is sulfur. That's why we write the sulfur in between the name of ligand and name of metal ion by the separation of hyphen. The another example is K2PT S2O3 twice. And the name of same molecular formula coordinate compound is different. Let us see one by one. Potassium dithiosulfato hyphen oxygen sulfur hyphen platinate second. Similarly for second coordinate compound, potassium dithiosulfato oxygen hyphen platinate 2. Here in first case the attachment via oxygen and sulfur, and in second case attachment or donation via oxygen atoms. The structure of both coordinate compound is like this. In first case the sulfur and oxygen are donate the electron density, but in second case totally 4 oxygen atom donate the electron density. That's why here 2 times oxygen and here 1 time oxygen and 1 time sulfur. The next point is abbreviations. Some ligand having long and complicated name. That's why while writing the naming of such type of ligand, we use their short forms. The example is EN. This EN abbreviation is used for the ligand, that is ethylene diamine. Similarly, PY abbreviation used for the pyridine ligand, and so on. The next important point is bridged ligands or groups. Basically, ligand that bridge two metal atoms in the polynuclear complexes called as bridged ligands or the groups, and such complexes is called as bridged complexes. Second important point is the Greek letter mu is used before the ligand name to represent the linkage of an bridged ligand. The example of such type of complexes is like this. In this case, basically, this hydroxy group and this hydroxy group is bridged between the two Fe atoms. Similarly, in this complex, this NH2 groups and NO2 group is bridged in between the two cobalt metal ions. And the name of such compound is mu dihydroxy octaaco diiron third sulfate. Similarly, the name for second complex is mu amido mu nitrito octa amine dicobalt third nitrate. Let us split this name one by one. Mu amido, that means this NH2 minus ligand is bridge in between the two cobalt. That's why we write the mu amido. Similarly, the mu nitrito, this nitrito ligand is bridge between the two cobalt. That's why mu nitrito. Octaamine, because 1, 2, 3, 4, 5, 6, 7, 8 NH3 groups, that is ammonium ligand is present. That's why octaamino. Dicobalt, because 2 cobalt atom is present, and that's why dicobalt. Third is because of oxidation state of both cobalt atom, and nitrate, which is anion present outside the sphere of complex. The next important point is geometrical isomers. Basically, name of geometrical isomers given by the three terms. First term is cis term. When two groups is in the 90-degree position angle or two ligands in the 90-degree position, then we have to give the name cis. Second term is trans. Trans is denoted for the opposite position of an ligand. That means the two ligand having bond angle of an 180 degree, then we have to write the name as a trans. And third type of nomenclature for the geometrical isomerism is an number system. This number system is generally used for the nomenclature of a geometrical isomer. It avoids the confusion between the cis-trans isomers. Let us see one by one. For example, for an square planar complexes and for an octahedral complexes, 1,3 and 2,4 position is trans position for an square planar complexes. Similarly, 1,6, 2,4, 3,5 are trans position for the octahedral complexes. Let us see with the diagrammatic representation. For square planar complexes, 1,3 position, that is this position 1, this 2, this 3 and this 4, 1 and 3 position having bond angle of 180 degree. And that's why 1,3 position and 2,4 position are trans to each other. But position 1, 2 ligand, 2, 3 ligands or 3, 4 ligands or 1, 4 ligands, that means the angle is 90 degree, then the position is known as cis position. Similarly, for octahedral complexes, the numbering is like this: 1, 2, 3, 4, 5 and bottom 6. This ligand 1 position and this ligand 2 position, or this ligand 1, ligand 3, ligand 1, ligand 4, ligand 1, ligand 5 are cis because the bond angle is 90 degree. But ligand 1 and ligand 6 are trans because bond angle is 180. And that's why we have to keep in mind, when two ligands having bond angle of 180, then these two ligands or these two position are trans, and when bond angle is 90, then this position is cis. And that's why 1,6 position, 2,4 position and 3,5 positions are trans in the octahedral complexes. The next important point is optical isomers. This system is similar to that of optical active compounds for an organic compounds. When coordinate compound rotate in the plane of plane polarized light in the right angle, then the compound is dextrorotatory and is denoted by using the symbol plus sign or small d. Similarly, when coordination compound or coordinate complex is rotate the plane of plane polarized light in the left hand side, then the complex is levorotatory and denoted by using the symbol minus or small l. And the example: potassium plus or D trioxylato iridate third. The next important point is chelate group. Basically, multidentate ligands having tendency to donate the electron density through more than one atom via the same molecule to the central atom or ion result in the chelate compound formation. The cation in the chelate is called as chelate ion and the ligand is called as chelating ligand. Let us see the example. Ethylene diamine. The example of complex is, the structure is like this. In this case basically copper metal ion forms the 4 coordinate bond with the 2 molecule of ethylene diamine, and that's why the resultant coordination compound is called as chelate. And the name is bis ethylene diamine cobalt 2nd sulfate. This is all about the writing the IUPAC nomenclature for an coordination compound. In the next video, we will discuss about the factor affecting to the stability of an complexes, stereochemistry of an different geometrical complexes, and difference between the complex and the chelates. Thank you for watching.